All right, so this is Unit 2, Day 2. We're going to graph absolute value functions. So a couple things you need to know. First off, this is what an absolute value graph looks like. It's a V, because remember, you're never going to go negative. So when the x's are negative, your actual y value, your output, is still positive. So that's why the graph points up in both directions. Over here, this is your parent function. It's as simple as it gets, just the absolute value of x. And that's what that graph looks like. Your vertex is at 0, 0. And from there, if you notice, every point goes up 1 over 1. So it kind of works like a line with the slope of 1. It just, instead of continuing the pattern, it actually stops and turns around and uses the pattern in the other direction. So the vertex is the point where the graph stops and turns around. That's going to be really important. So the vertex for this graph is right here. This point is what we're going to base everything around. These are the quick notes for graphing absolute value. This is what the transformation equation looks like. So we're just going to take that parent function I showed you, and we're just going to change it according to A, H, and K. So A acts like your slope. Like I said in the first one, it kind of has a slope like a line does. If A is positive, it opens up. If A is negative, it opens down. So that's the same as if on a line, it's increasing when it's positive, decreasing when it's negative. And then the actual A value tells you how far apart each point is, rise over run. H will shift your graph left or right, and that you can see is inside the absolute value bars. So it lies to you though. X minus H is actually going to move your graph to the right. It's actually going to move it positive. X plus H, you would expect it to go negative, but it goes to the left. So the one thing to remember about H is that it sort of lies to you. But K doesn't lie at all. It goes, I make myself laugh. It's straight up, literally. If it's a plus 3, that graph is going to shift up 3. If it's minus 2, it's going to go down 2. So K does exactly what it says. So we have 2 examples that we'll fill out together, and then one I want you guys to try on your own. We'll graph in class, but remember that graphing on my notes are terrible. So we're just going to write the equation given descriptions. So we're taking the function f of x equals the absolute value of x, and I'm going to shift it down 7 and left 3. So if you go back to the notes you wrote before, down 7 is k. So that's going to be down 7. To the left 3 is h. Since I'm changing f of x equals the absolute value of x, I'm just going to give it a different letter. So I'm going to say g of x. It doesn't say anything about it's flipping or opening up or down, so I'm just going to keep it how it is. H is moving to the left 3, so remember that's where we said H lies to you. If it's moving to the left, that means I have a plus 3. K is shifted down 7, K doesn't lie and does exactly what it says. So this is the equation of the absolute value graph that moves left 3 and down 7. For the next equation, it says the function f of x equals the absolute value of x, so for your parent function, it opens down and it's shifted to the right. So opens down, this means that A is negative. Shift right 4, right is going to be H, and again, H kind of lies to you. It doesn't say anything about moving up or down, so I don't have any K value, so I don't need to write that. So for this one, I'm going to say g of x equals, I'm going to put a negative in front of the absolute value, and then if it's moving to the right 4, that's going to be x minus 4. And then again, it doesn't shift left or right at all, it doesn't shift up or down at all, so that's my final answer. So after seeing those 2 examples, can you come up with the equation for a graph that is shifted right 4 and up 2?